Hi, this is Nathan Tintle. In this Learning Goal video, we will talk about how to do follow-up tests after you've done an overall test using the MAD statistic. We will use the Coming to a Stop dataset to talk about this learning goal. The p-value from simulation using a MAD statistic for this dataset is approximately 0.08. If you used a more liberal significance level of 0.1, this result would be considered significant. So if we have evidence that at least one proportion is different from the others, that is, we have evidence that the alternative hypothesis is true and at least one of the types of cars is stopping at a different frequency than another, what do we do now? If you told someone on the street, we just did this analysis, we have evidence that at least one of the types of these cars is different from the others, the person would probably say, which one, or which ones are different. The MAD statistic isn't answering that question for us, so what do we need to do? Now we're going to do a follow-up analysis. Most times the follow-up analysis looks like this. We're going to take each of those proportions and compare them to the other ones. We could use 95% confidence intervals to do that. That's what I've done here. We can take the single minus the lead, get a confidence interval on that difference, on all of the differences. There's 3 differences in total. We put an asterisk next to the confidence interval here that doesn't include 0. What does that mean? This means that when we're looking at each of these types of cars versus the other types, the lead car versus the following car difference in stopping rate is substantially different. It's significantly different. We're estimating anywhere between 0.8% and 25% more stopping if you are the lead car as compared to the following car. So what does this approach do? Well, it's really a two-step approach. You first do an overall test. Some people call it an omnibus test, which is just a fancy word for overall. That's using the MAD statistic. By doing that, you control the overall type 1 error rate. That is the chance that you make at least one mistake. It's only if that test is significant that you look for differences between the groups. We've showed you one strategy here where you follow up your overall test, say using the MAD statistic, with a series of 95% confidence intervals on each of the differences. There are lots of other more sophisticated options that are out there that people use in practice. The general approach, though, is the same. They're going to take all of the different groups and compare them to each other. What's really different between these more sophisticated approaches is that they're tweaking the confidence level at this post hoc or follow-up stage, and that's changing the width of the interval a little bit. You typically need advanced statistical software to use these methods. They're not the kind of thing that you can do by hand. So we've chosen to show you this more basic method, which builds on what we've shown you before. Just realize in practice you will often see these slightly different, more sophisticated methods that take the same general approach of comparing all the groups to each other.